I think one of our big plays as well and bets is that by being able to leverage the power of the tools that we are near, so like MetaMask, right now there's like a default integration. Correct me if I'm wrong. I think as a developer, like the idea of clicking an add network button is like, no sweat off my back. Like I'm okay with that. But if you actually dig into the data, there's a significant amount of churn in a transaction signature just from that one step, right? So that's already like a really powerful play as to like Linea fitting into that ecosystem. I think the other piece, if you aren't familiar with like the full tool set of ConsenSys, we also have the Besu client, where we have a Besu client, and now we're leveraging that as well to be a little bit personalized for Linea as well. So that is also just like a piece of extra, I guess, specialness that allows us to be a little bit faster, more stable, more compatible, that really enables us to build cooler tools.
Hello and welcome to another episode of Devs Do Something. Today's guest is Emily from the ConsenSys team, and we deep dive all things Linea, which is the new ConsenSys ZK EVM. So this episode features a deep dive into how Linea works, right? So things like the sequencer and the prover, as well as just more general things about ZK rollups and ZK EVMs in particular. So we walk through different categories, as Emily calls them, of zero-knowledge scaling solutions, right? Everything from, why some teams choose to be ZK EVMs and really map their functionality such that everything is consistent with the EVM, and why some other teams decide to do their own thing, right? Teams like Starknet or ZK Sync that have gone off and decided to not retain parity with the EVM for their own reasons. And we walk through how these different trade-offs exist and how different teams make those decisions. We also walk through some of the research that ConsenSys has done on ZK EVMs, as well as just what Emily is excited to see launch on Linea. So Linea right now is on, it's I guess in a testnet phase. You can play around with the test network right now. They have different voyages where they're kind of asking their community to do different things on the chain as they prep for a mainnet launch. But, if you're a dev that's considering launching on this new network, or if you're just curious about how ZK EVMs work and the broader ZK EVM space, I think you're going to really like this episode. So sit back, relax, and I hope you enjoy. As devs, we all love hackathons. They're a great way to boost your skill set, meet other engineers, and add to your portfolio of work. At Superfluid, we've sponsored many hackathons and decided to start putting on a hackathon of our own, the Superfluid Wave Pool. This hackathon is a little bit different though in that it's continuous, it's always open. You can submit any project built on Superfluid at any point throughout the month and have a chance to earn thousands of dollars in prizes depending on how your project stacks up. In just the last couple of months, we've seen dozens of teams build really amazing projects that run the gamut from Superfluid developer tutorials to full-fledged applications to a proof of concept Superfluid Starknet implementation that we thought was really, really impressive. So we encourage you to check it out today. You can learn more by going to superfluid.finance/wavepool. That's superfluid.finance/wavepool. Happy hacking. All right, so we are back today with another episode of Devs Do Something. We're going to focus on ZK EVMs today, and we have a special guest, Emily, from the ConsenSys team to talk about all things Linea. Welcome, Emily.
Hello. Hi, how are you doing?
Yes, it's great to have you here. We've met each other at various crypto events around the world, but it's good to have you here today to deep dive Linea. I'll say that a lot of our listeners understand the general concept of ZK EVM, but I would love for you to give us a general overview of Linea, and then we can dive more deeply into things from there.
Linea is a ZK rollup going for a type 2 ZK EVM. Vitalik posted a paper. There are 4 different types. The type 4 being the farthest away from Ethereum. So type 4 is high-level language equivalent. So that's going to be, I can write in Solidity, but it compiles down into a different bytecode. So that means for developers specifically, if you're using tools like Hardhat, Foundry, Truffle, you'll have to install a separate plugin just so that they can understand it. Protocols like that use this are going to be like StarkNet and ZK Sync. As we move further down, let's skip to the very type 2, maybe. So type 2 is going to be where Linea is going for, right? So type 2 is high-level language equivalent. I can write in Solidity. I can write in Viper. Bytecode equivalent. So it covers all the precompiles and opcodes of Ethereum. What this means for a developer specifically is I don't need to change my tooling stack at all. I get to leverage the network effects of, things like my I guess development environments, again, Truffle, Foundry, CLI, all or Hardhat, all understand it immediately. There's no switching costs. So like individual things that you might worry about of like, oh, is this covered? Is this not? Should not be part of your concern. And that's kind of where type 2s sit. Type 1s are going to be Ethereum equivalent. So they're exactly the same in every way. I don't know all the differences. I think the most material difference for a developer is the way the data is hashed. I'm going to say it's something like Ethereum uses like Kachak hashing. I don't remember what the zkEVMs do off the top of my head, but some devs actually do use that hash function specifically in their code. If you do, that's something you'll need to keep in mind. But essentially, that is the 4 different types. I could dive deeper into the trade-offs and why you would do type 2, type 4 if you're interested, or we can stop here because that was a lot of information.
Well, let's come back to the trade-offs between types in a bit, because I think that's pretty relevant for developers to understand this entire space. But before we do that, can we maybe walk through a standard transaction and what it might look like under the hood in this environment, right? So let's say that I'm on Linea and I want to send a token to you. So I'm just going to do a standard ERC20 transfer. What actually happens under the hood as that transaction is processed?
Cool. Yeah. So basically the transaction, say you're going through MetaMask, right? So the transaction is crafted together by MetaMask. And then the signing is then pointed over to the RPC endpoints, right? So that's going to be something like Infura. After that, the Infura gateway will load balance that across various validators, for which during there's going to be a 12-second block mining time period for Linea specifically. We do plan on changing this for 1 to 3 seconds in the future for throughput and latency, but right now for testnet, it is a 12-second block mining time. After that, the new block is propagated, and an EVM execution trace is generated. And then that trace is going to be fed into our proving system, which is composed of an inner proof, which we call Vortex and Arcane, and then an outer proof, which used to be Groth 16, but will now be Plonk. And after that, we have the proof, then it is sent back to the L1, and the L1 verifier contract will say, yes, this is true, I'm going to commit it. So then the Merkle state commitment tree and the call data will be put back to Ethereum L1 for data availability. So that is a transfer.
Nice. Very concise, and even starting with the Infura endpoints, which is interesting. Yeah, you have to plug Infura a little bit, right? Infura is a ConsenSys product, right?
Yeah. I mean, I'm just saying if you're asking about like Linea specifically, right? Okay, we can replace it with like a different RPC URL if you're using a different ZK EVM, obviously. But right now, if you're making a transaction on Linea, it does go through Infura. So that's why I mentioned it.
Of course. Well, all love to Infura. We all love Infura. Infura and Alchemy, we all get started with both of those. Okay, so you mentioned the block time bit. Why the 12-second block time? Is this something that is there because it's a test net, most of the nodes are being run by the ConsenSys team? Is this like some kind of hard set thing? Like, what is there a reason behind the block time, like the speed at which different blocks will be propagated, or no?
Yeah. So my understanding is just more of a testnet thing. It is going to be like something like if bots are spamming the network, for example, you don't want your block time to keep propagating things. Just keeping it slower is better when we're at this stage. For mainnet, we do plan on increasing or I guess decreasing the time to increase throughput. But yeah, you're exactly right.
Got it. Well, I can read between the lines there on, dealing with botting and things like that at this stage of the game. So on
Yeah.
on the node side, this is maybe a separate question. We don't have to go too deeply into this, but if I want to run a node on Linea right now, is like the software open source for that yet? I mean, I know eventually it will be, but like if I'm more on the DevOps side, can I get involved? Like what are the steps there?
I mean, I think the answer is right now, I think it's no, but obviously yes in the future. So if you are curious, please reach out to me. You have my Twitter somewhere in the information of the podcast. But yeah, right now we are a centralized node. I don't remember the basics of this. But yeah.
And then what goes into the actual mainnet launch? Like what kind of steps need to be, what kind of tests need to be passed? What kind of things does the team feel like need to be in place before the official mainnet launch?
Yeah. So before mainnet, I think there are a few things that need to be sure. Like number one is security, right? So we have smart contracts that are being audited by multiple security auditors, bug bounties, things like that. So smart contract security is like the most important piece. The other piece that we're doing right now is obviously like just spamming the system. So that's kind of where we are at right now. If you're familiar with the Linea voyages that are running. So Linea voyages are essentially a series of like off-chain and on-chain tasks. On-chain being the weeks where we ask the community to do certain on-chain activations to make sure our testnet is stress tested and we're exposing like different types of transactions that we could potentially experience on the test net. And then the off-chain weeks are for like our systems to cool down, our engineers to go in and make changes, address any issues that they might have found during that on-chain week. And so there's that piece, like that's the technical part, right? Stress testing, finding bugs. And then obviously in a mainnet launch, there's also like the big marketing push, the ecosystem push. So really heavily kind of on like the developer relations and business development side, right? Success on a tooling chain, or sorry, a roll up or whatever, is not predicated just on like prover time. It's predicated on ecosystem, right? So you don't want to go and join a mainnet that's like an empty ghost town. Developer tools that exist in infrastructure on other chains don't exist on your chain. That's not a great look either. So it's a combination of both like the tech needs to be hardened as well as like the city needs to be populated before you can get to mainnet.
Yeah, I think the city analogy for new chains is actually a good one. I think one of the GPs at Dragonfly Capital wrote a really good piece about how blockchains are like cities. So I think that probably is the right sort of analogy. But what kinds of applications, and this is a big part of your role, what kinds of applications are you really excited to see launch on Linea? Like what are some of the things that you think would be great initial deployments for you guys on the network?
Right. Yeah. So I want to dive into saying that this is my personal opinion of what I'd love to see kind of Linea's killer dApp to be. Is definitely, I think gaming is what's really exciting, right? Because when we talk a lot about scale, it is scale in regards to games, right? Because games require really fast transactions, really cheap transactions if things are happening often. I think the other piece of like why I would really like to see gaming on Linea like kind of grow as well is because gaming, I think, is like the stickiest type of dApp that exists. So it's a hard place to break into because I feel like there hasn't been a universally agreed upon like this is the funnest game in the entire world that's been in Web3. I think also because gaming kind of started out as GameFi, which is not a good look, I think, for your average gamer. But if you can make a fun game on a Web3 in a Web3 context, right? Like I think that is what will create stickiness. That's what generates the most transactions. If you actually look into like MetaMask data, I believe, I think like gaming dApps generate the most traffic, right? Outside of DeFi. And so that is kind of where I would love to see people building.
Yeah, I love it. Gaming is one of those things right now that actually has a chance to bring new people into this ecosystem, get them to try, installing MetaMask for the first time, and get them some experience with some of these new technologies in a way that's fun and pretty low stakes, right? It's kind of difficult for governments to regulate gaming out of existence and things like that, right? So I think in general, I've noticed that a lot of the industry has started to point towards gaming as like a great area to focus on for right now. Um, so I think that's definitely a good sector. And then if we go back then into like why you guys have made some of the design decisions you've made, we'll come back to the tooling side later on. I have a whole bunch of questions on like tooling you guys have built and even like the prover and all of that good stuff that I want to get back into. But if I'm a game and I could deploy on Linea or an Avalanche subnet or the Polygon ZK EVM, I have some options. And part of our listener base are people that work at DeFi protocols or they are in Web3 game development. They're smart contract folks. They're trying to understand what environments they should prioritize, right? So I guess what I'd love to understand is maybe we can start by going back into this whole idea that there's different types of ZK EVMs and each of them come with different trade-offs. So I'd love for you to maybe speak about what some of those trade-offs are that you alluded to earlier when it comes to ZK EVMs that are type 2 ZK EVMs, or maybe, the type 4 examples that you also alluded to earlier. So maybe we can unpack that, and then I'll ask a few other follow-up questions from there.
Cool. Yeah. So basically, you can kind of think like type 4s as like the first ones that came out. They are the farthest away from Ethereum. So in a sense, they were also the easiest to build. The reason I guess type 4s exist is because Ethereum specs are not ZK proof friendly, right? So I think the thesis there for a type 4 is saying like, hey, we're going to depart a little bit farther from the EVM so that we can be faster. So the trade-off they're making is, we'll be a little bit farther from the EVM, but we will get the prover times that we want, the data size, et cetera, right? Another piece I think that ZK Sync was pushing a lot too, as well as like, because they are a little bit different, they can build a native account abstraction. And that's kind of where type 4 is saying is like, we can have the best of both worlds, essentially, right? The type 2s, I think, are in the game of like, what do you call like network effects, right? So you can think of something like Starknet that first came out when they only had Cairo. So just to circle back, I think Starknet was not a type 4 until they came out with their transpiler. Meaning before when they came out, you could write in Cairo. Later, they have a transpiler. So now Solidity compiles down into Cairo. And that's why it's a type 4 now. But to circle back to that example, right? You have to find like a whole new army of smart contract auditors who like understand Cairo, right? Whereas when you are going to be bytecode equivalent, that kind of ecosystem effect doesn't need to change, right? You just take advantage of the tools you have now. The other piece is Ethereum. The Ethereum spec is constantly changing as well. So the farther you are from Ethereum, the harder it is to like maintain parity and be close to it. And so that's kind of the I guess battle cry of the type 2 ZK EVMs is because we are betting on Ethereum and want to stay close to it. So the primary trade-off that, people will say is going to be equivalent, like compatibility versus speed. I think on Linea's end, actually, with our prover tech that we've been improving on, our assertion is actually that's not the case anymore, that we can find that balance between, I guess, being friendly for ZK proofs, as well as maintaining equivalence to the EVM. So that's kind of where that sits in terms of the trade-off tech between type 4s and type 2s. I can also dive into the differences between the different type 2s if you would like, but I can also stop there.
Yeah, I think I have a question actually earmarked that I want to ask you about different type 2s, but just to double down on the trade-offs between maintaining EVM equivalence and not, right? So I think one of the things that maybe Starknet or a ZK Sync type, like areas where they have advantages and that they're not bound to all of the the other requirements that the Ethereum virtual machine, has to sort of maintain, right? They get a bit of a blank slate. They can start over from scratch, right? There's EIPs that maybe have sat on the shelf for a long time that might have been good ideas that just didn't get implemented, that those other environments can just implement from day one, right? Like the econo abstraction example. And I think there might always be a demand for new environments like that can start anew. One thing though that is true is that, like you said, the EVM spec is constantly changing a bit. Like I've heard other people say that they think in the future that Ethereum will actually be like frozen at some point. I don't know if that will ever happen. Software always seems to have to change in some capacity. But how does the Linea team think about like actually keeping up with changes in the EVM? Because the like Linea is going to have to also make changes to maintain that parity, right? So is that something that your team thinks about much, or is that maybe a set of worries for a later date?
I think we probably think about that all the time because it's changing as we speak, right? So if your goal is type 2, your goal is type 2, right? So that's why we want to be as close as possible. I think also something is like saying built-in like native account abstraction, just to like nitpick on that piece specifically. It's right, like you could say like I took the time to build this in, but like, hey, wait, no, actually now we have EIP 4337. Like Ethereum is like making gradual changes to get those features in, and it becomes a thing of like how much time do you want to commit to my chain versus the entire ecosystem is already built on top of something that is going to incorporate like your feature a little bit later, right? I don't know. But it could go either way. I do want to note as well, it's not kind of a winner takes all situation. If I'm going to be honest, I think like interoperability, like the real winners, I think in this whole space are going to be cross-chain tools. Because my vision is we go to a world where we're not even thinking about what L2 that we're on. So
yeah, I think you're definitely right about that. It's actually the nature of like block space being scarce kind of prevents there from being a true winner take all environment. And to your point on the account abstraction thing, I do think that there is some value in starting over and trying to improve things at the level of the chain itself. However, I think one of the bets that your team is making and the other teams that are trying to be EVM equivalent are making is really just that the Ethereum ecosystem is a very powerful thing in and of itself, right? So you're kind of riding the ecosystem, and that's actually that's a pretty good bet because I don't see the Ethereum ecosystem going away. It has very strong network effects that make it so that it'll probably be around for a long time, right? Even if something else comes out that it is technically superior, people will still use the EVM, right? It will be successful.
I think this goes back to what you were saying about like the city needs to be built, kind of thing, and there needs to be a population there. So probably why like your job is so important, right?
Exactly. Like you could have a city with amazing buildings and great roads and infrastructure, but if no one is there, then how valuable is your city really? That's the real question.
Right. And I do want to touch on like how this kind of also fits into the Linea's thesis. So we can talk about the prover technology if you want to later, but I kind of also wanted to touch on kind of Linea's strength as sitting within the ConsenSys ecosystem. I think one of our big plays as well and bets is that by being able to leverage the power of the tools that we are near, so like MetaMask, right now there's like a default integration. I think, correct me if I'm wrong, I think as a developer, like the idea of clicking an add network button is like, no sweat off my back. Like I'm okay with that. But if you actually dig into the data, there's a significant amount of churn in a transaction signature just from that one step, right? So that's already like a really powerful play as to like Linea fitting into that ecosystem. I think the other piece, if you aren't familiar with like the full tool set of ConsenSys, we also have the Besu client. So basically, we have a Besu client, and now we're leveraging that as well to be a little bit personalized for Linea as well. So that is also just like a piece of extra, I guess, specialness that allows us to be a little bit faster, more stable, more compatible, that really enables us to build cooler tools. So yeah, if you want to feed further into that like populated city kind of analogy, that is our ecosystem bet on the Linea side sitting within ConsenSys.
Yeah, that's definitely valuable, and it will make it easy for you guys to use the infrastructure you've already built to make sure that the user experience is good and the developer experience is good. But can you walk through that? What is the you said the Besu client? Please spell that for me. Is it BASU something
Yeah,
else?
yeah. So it's BESU, right? It's an execution client. So it's Geth. But now we are building something called zkBesu, which is basically an execution client of zkGeth. And because it's in-house, and it's like Besu already powers a lot of Ethereum clients, so it's like pretty battle tested, very like commonly used. And now we're just leveraging the fact that we have that expertise, and I guess like what do you call tool in-house, to build compatible execution clients for Linea.
Yep. And then one other piece of tooling I'd love for you to unpack is the Linea bridge that you have that's like hosted on a separate site. I think, is that like a partnership with Hop, or is that something you guys built internally?
Yeah. So we have a canonical token bridge. It's what do you call it? It uses the Hop UI front end. But basically, this is a token bridge that allows you to pass, again, token information, arbitrary messages, and yeah, it's pretty flexible. I haven't worked with it directly, I'm going to say, but I think it's a pretty standard thing bridge rollups have. Um, and basically allows you to initiate network to network transfers, of both data and token.
Nice. And that kind of, so again, we're going to unpack the prover, I promise. But how does, you actually just mentioned something a couple of minutes ago that I want to really unpack as well. You said that the winners in this space might all end up being the interoperability providers and people that make it easy to kind of abstract away the experience of picking a chain and, being dogmatic about I use this chain or that chain, right? Like how do you see this market for block space itself evolving? Like one thing I was just talking about with the Superfluid team this morning was this product that Connects recently released, this chain abstraction thing where they just kind of abstract the chain itself away from the user, right? Like how do you see that evolving, right? I mean, I think, obviously people like the team working on Linea and all, similar L2s will definitely help improve UX, but I mean, do you think that the actual infrastructure is going to fade into the background soon? Or will we always live in this space of, you have to choose your network every time and know a lot about each one and really exert a lot of brain power on that?
Yeah, I mean, if you want to dumb it down to the simplest, it's like if you want Ethereum to be successful, you want users to not have to exert a lot of brain power. So, like, my personal feeling is like, I think it will fade into the background. Like, if anything, like L2s will just kind of be just your like default scaling layer. If you think about like internet right now, does anyone understand the plumbing behind it? No, not really. Um, but I think L2s kind of. Well, let me dive a little bit. Let me take this in a different angle, right? I think what I want to say, right, when I say it's not a winner takes all situation, is have you heard of the multi-prover theory at all?
I have not.
Okay, cool. So I'll get into that, right? So if we live in a world where there are just like a bunch of like I should say single L2s, and people have to choose in between them, that's actually a pretty dangerous state to be in because each L2 has their own way of doing their own ZK proof, right? And so if there's a bug on it, that's a centralized point of failure, which is like really problematic. So the multi-prover theory is basically saying, hey, we need to actually live in a world where we have a decentralized sequencer that's going to be passing information basically to multiple provers so that if like my prover, let's say like Linea's prover says something is true, Polygon's prover says something is true, but Scroll's prover says something is false, then that's like a problem, right? So that is a much more secure trust assumption to go through kind of a multiple prover system rather than just living on a single chain, right? And I think that's like the future that we are hopeful for. And again, all of that stuff, if that were to be successful, right, that is again another case for like, okay, yeah, the chain's just in the background, right? And what's the more important part is how these chains communicate with each other. So I guess to circle back to whatever the first question was, is yes, I think Connect's making that choice of like chain abstraction is actually a really powerful move. Yeah.
I love that. Yeah, I think that's a really interesting idea that we could go up one level higher and say, okay, let's think about all of these different provers as things that could, in theory, create another layer of emergence and have another kind of a consensus layer even above what we already have as a way to increase security. That's quite interesting. What about what about this idea of like L3s? Like, will these ever enter the discussion? Like, are we just going to keep building up like higher and higher above the EVM, right? Like, if for example you guys crush it with the launch of Linea, does that mean that people will try to build additional scaling solutions on top of the L2? Does that mean we just eventually have L6s and L7s and data availability becomes a problem? Like how do you see that playing out?
Yeah. So this is a really good question. I think the first part addressing is like the definition of an L3 isn't even stabilized yet. So maybe to address kind of what you described, right, of like a scaling solution on top of a scaling solution, I don't think that will make sense or happen. Because when we talk about like, I guess, scaling solutions, like rollups, there's kind of two vectors of where you would scale, right? So it's in the computation side and then the data side, right? So the computation side, yes, we can recursively apply proofs on tops of proofs on tops of proofs, which makes it smaller and smaller. So a rollup on the top of a rollup, if you're just talking about computation, that makes sense. But for data, like the way data hashing compression techniques work is you can't do it more than once. So that doesn't really make sense if you think about the scheme of like an L3, right? So I think what's been popular in terms of exploring the L3 space and beyond, there are a few different proposals of what that could be. The one that resonates the most with me is going to be like, I guess you could say use case specific application. So L3, don't think of it as like a scaling solution so much as like maybe a privacy solution, for example. So I think like StarkNet has something like this already where they have like StarkNet is their L2 scaling solution. I forget who or what, but they also have a separate privacy solution built on top of StarkNet, right? So if you want a private blockchain that is then also scalable, then that commits their information to Ethereum. That's possible with like this 3-layer and above architecture, right? And so that's kind of one definition. I think that does make a lot of sense for the L3 and beyond space. I think it's just very confusing because L3 doesn't have like a finalized definition in the same way L2s do. But yeah. I mean, if I were to make my bet, going back into like, do L2s fade into the background? I would say yes. And the actual kind of space where people are going to be fighting is going to be the L3 and app chain space for like very personalized environments. Like if you're building a game, yes, you want the scale of an L2, but games are also very, very complex. They'll probably need specific things that are special to like the way maybe I don't know what goes into building a game. Their people battle each other. This creates like this type of data scheme that's the best for running their application efficiently. And then that would be like an L3, right, on top of like the generic L2, for example. But yeah.
Super interesting take. Very interesting. Okay, that's relevant for our game dev listeners for sure. Maybe if they're thinking about the future of where they want their game to live. Okay. One more question that's more general market-based here for now, and then we'll get into the prover and we'll get back into the hardcore technicals. But one thing that has been a bit of a topic of debate, I see it a little less in debate now, but people for a while I think kind of saw, and maybe they still see it this way, they saw optimistic rollups as a sort of medium-term solution or medium-term technology where, optimistic rollups were a known way to scale Ethereum, right? You had Optimism and Arbitrum launch, you had others launch, but a lot of the rhetoric around optimistic rollups were that it is like the system is inferior in certain ways to ZK rollups. The problem is that ZK rollups are this kind of futuristic technology. We don't know how to do them. But for now, though, it seems as though teams like yours have figured out the technical piece behind ZK rollups, right? So how do you see this evolving? Like, will these things coexist for a long time? Will new optimistic rollups launch and be successful? How do you see this playing out?
Yeah. Oh, this is spicy. I hope I don't get attacked for this. I think okay. I don't want to speak on the behalf of Linea. I want to speak on behalf of what my opinion is. That's okay. Maybe that is somewhat reflective of Linea's opinion. But yeah, I think going again back to the thing of populated city, right? I think optimistic rollups and ZK rollups will still live in a state of coexistence for a while. Right, because optimistic rollups were the first one out there. Arbitrum has a huge amount of TVL on it and activity, and to say that they're just going to be made obsolete because of ZK rollups, I think is a little naive. I do think in the long run, though, right? And this is my understanding too of the optimistic rollup roadmap is they are starting to incorporate ZK into their protocols or roadmap plans, right? So it's not optimistic rollup, the existing optimistic rollups won't exist anymore. They just will probably move over into a ZK proof scheme. Because, so I think there's going to be a time where we're going to live in this, there are optimistic rollup and there are ZK rollups and they exist at the same time. Does that matter as much when we have cross-chain tooling that will connect apps through EVM equivalent chains? I don't know. But it eventually does matter when you start to think about fluidity of, assets flowing across with regards to I guess as long as optimistic rollups exist, there's going to be capital inefficiencies because of those withdrawal times from, when you withdraw from the Ethereum L1, right? So we're in this weird period of, yes, optimistic rollups, ZK rollups will exist. They will coexist. I think optimistic rollups will eventually find their way towards ZK so that we can have those the faster finality, the recursive infinite scaling, and things that you need for just a very fluid and fast transaction cycle. Yeah. So I don't remember where I was trying to end my thought, but the point is, I think Linea definitely is lucky in the sense that we came out with as a ZK rollup, started off in, I don't know if you know the history of Linea. Actually, we started off 4 years ago doing research into privacy payment solutions. So just really heavy ZK research with regarding to privacy, and kind of through that process realized that the type of research we're doing was actually creating, tech that was very useful for ZK scaling. And that was kind of the pivot into how we were able to get Linea to where it is today. So yeah, definitely lucky, I think, for sure.
Yeah, well, you're well positioned too. I mean, it's not all luck. The ConsenSys team is very well positioned.
Yeah, that's true. That's true. What am I saying? My team members are so smart. I'm discounting them. It's 100%.
You never know what's going to happen, right? You can't predict the future growth of complex systems and knowledge like this, right? So, I think other people kind of, traveled similar routes. Like people that got really into ZK, I think a lot of people were nerd sniped by the privacy bits, and I think even people that are building ZK tech, I think even if they are using it for scalability right now, I think a lot of the hardcore ZK engineering folks do have privacy related things they want to build, or at least aspirationally want to build. So there's some interplay between the two for sure. But I don't think your take was too spicy. I think it makes sense. And I think there are real questions that need to be answered when it comes to Yeah, the period in which you can make a fraud proof being 7 days, and these things having to interoperate with other systems that have like that don't have that same 7 day or however many day requirement, right? That could create some weird uh, security style problems that result from like us stacking these Lego bricks on top of each other, right? So let's see how it plays out, but I think it's a worthwhile thing to think about. But okay, let's go back. We've been talking about the prover. We've been alluding to the prover. The prover is actually a way that a lot of, yourself, the Polygon zkEVM team, the other zkEVM teams, it's a way that each of your teams kind of try to differentiate, right? There's a lot of research that goes into the prover, a lot of novel technical ideas that show up in the prover. So I would love for you to kind of walk us through the prover architecture with Linea, and maybe I can ask a couple of follow-up questions from there.
Yeah, okay, cool. So I'll try to give you the laydown of everything I understand, which means a lot of the math is going to be abstracted away, and I might talk around things a lot, but hopefully we'll get there. So essentially, the way Linea's prover works, right, is we have something, you could think of the flow as we start off with arithmetization that goes to an inner proof system, that goes to an outer proof system, that basically generates a proof to be verified by the verifier contract on Ethereum L1. So to kind of, I guess, step through each part of that process, arithmetization is basically the process by which computer programs become math for ZK proofs to understand. I know that Linea is doing like really special stuff on the arithmetization part. I'm actually not too familiar with it, so I don't feel comfortable explaining it. I do want to say there is a talk they gave on DevCon, I think, around the arithmetization point that you guys can look up from last year, as well as if you'll be in Paris, they're doing a talk on the arithmetization technology in July. And there's like random research articles floating around. But anyways, that part is how we differentiate ourselves. I don't know how exactly, so I'm not going to get into it. But essentially, what that does is it creates like math, right? And so now we're in the state where we've turned like the transaction into a set of traces and constraints that need to be verified, proven and verified, right? So the first thing it does is it sends it into an inner proof. So the inner proof is basically comprised of something called like arcane and vortex. I'm going to go ahead and completely skip over this and actually jump to the end, right? So the end is the outer proof. So the outer proof, actually, no, let me just, you know what? I'll just go step by step. I'm not going to jump to the outer proof. So cycle back. Arithmetization, we go into the inner proof. So the inner proof is comprised of arcane and vortex. So essentially what happens here is that the, like, what do you call it? This is another piece that makes Linea different, and I'm also not going to explain exactly why. But I think in a standard prover system, we have like everyone does the arithmetization part, right? And it turns it into something called interactive oracle proofs. And so IOPs are actually a system set up such that the verifier does not have to get all of the information about the trace from the prover. Rather, it speaks through a third party called an oracle and basically is able to query information from that oracle back and forth, right? So that's kind of what an IOP is. And in that case, this IOP, I know basically Linea's version of the IOP is called a wizard IOP, which is actually pretty fun. The high level important part of it that makes it interesting is basically it allows more, I guess, these queries to be made more complexly and at a higher level of abstraction than like a standard IOP. So that's like, so the arithmetization part is different. We're a little faster. IOPs, we have our own kind of refinement on top of it. And then we finally get into, so this portion of like the IOP basically communicates, or what do you call it? It compiles down the information into a set of polynomial evaluations. What this is basically saying is like, we need to verify that these traces satisfy some constraints. Constraints are actually not very easy to prove. So we want to transform them into something more homogeneous. From a mathematical point of view, just being able to evaluate polynomials is actually a lot easier. Why does it? I don't know, but that's how it works, right? So Arcane is going to be that first step, right? Where we are transforming all of this information into polynomial evaluations that can then be transformed into polynomial commitments. And so polynomial commitment is kind of where the vortex part comes in, right? So vortex is actually going to be our lattice-based hashing. So to take a step back, basically, lattice-based hashes are really interesting because they are faster than the popular kind of elliptic curve cryptography that exists right now. This is actually really fun. They're plausibly post-quantum. So that means that lattice hashes are resistant to quantum computing attacks. They are plausibly quantum computing because that type of computing attack doesn't even exist yet. So who even knows? This could all be false, right? The other piece of why lattice hashing is really cool and makes Linea different is they are optimized for recursion. And then the last piece actually is they are very compatible with hardware acceleration and something called like single something multi-data parallelism. But I don't know, compatible with some special tech that is related to high performance computing architecture. But essentially, where lattice hashes fit in is basically how we translate this, I guess, the information coming in into basically hash data that the verifier can interact with, right? And so through a composition of Arcane, which is just going to be converting the arithmetization into this Oracle proof communication layer, which then turns it into Vortex, which is a commitment scheme that the verifier can then interact with. It does this recursively in such a way that this proof that you started off like the trace gets smaller and smaller and smaller and smaller and smaller. And that's what makes us really special. The last piece, though, however, is this proof is shrunk a lot. It's actually still not small enough to be shrunk to be put on Ethereum and verified by Ethereum. So that's where the outer proof comes in. So the outer proof then just shrinks that again. And that's where the snark comes in. So the snark being, it used to be Groth 16. And this is what I was mentioning before. It is now Plonk. So yeah, that's kind of where we sit. That was a lot. I guess to summarize, it's like we have math that becomes a proof that is made smaller and smaller and smaller and smaller through lattice-based cryptography, and then is finally compressed in a single step by a snark proof and then put to Ethereum L1 to be verified. So
wonderful. Yeah, thank you for the great overview there. I think that's a great introduction into what you guys are actually doing on the prover side. And then you also mentioned something in there that's actually kind of a pet interest of mine around hardware acceleration with ZK. I'll put a link in the show notes here that is some very updated research. I think it's from this CISIC blog, or maybe the CISIC team and Luke Pearson. But I'll put a link to this. I found this the other day, and it's quite a good article about the topic for those of you nerds out there that are interested in how ZK hardware acceleration might play out. But thank you for the overview. That's fantastic. Thanks for walking us through Lattice as well, because I was going to ask you about Lattice and Vortex and all that good stuff. One other question on the hardcore technical architecture and infrastructure you're building right now is around the sequencer. So one question that decentralization maxis like to ask, or at least they want to know, is how decentralized is the sequencer? Can I get censored from the sequencer? Now, the reality for all of you decentralization maxis out there is if you're going to go to market for the first time, especially when everything is in a test environment still, typically the sequencer is centralized just for the sake of going to market, right? But most teams have a kind of progressive decentralization plan. So, does the Linea team have any plans to progressively decentralize it? Is it meant to be part of this consensus stack, the consensus controls? how do you see like the decentralization happening with the sequencer itself?
No. Oh my god, I hope this doesn't come out as consensus controls Linea. This is false. But no. Yeah, I'll step through kind of our plan, right? So from day one, we will be centralized, as in day one of mainnet, right? But this isn't a problem for, I guess, users and developers. We will have a mechanism for users to withdraw funds in the event of something malicious or a missing operator happening. And like at the end of the day, all this data is committed right to the L1. So you have that security and data availability. But aside from that, like plans after mainnet that's going to be kind of like the next step, right? So the smart contract, roll of smart contract has upgrade keys. So all of that, like, I guess that is to say we have plans for it. It's built into the way that we've set up Linea. But yeah, for those of you coming onto Linea for mainnet, expect it to be centralized. There are alternative routes if you want to pull out your funds. So don't worry.
All right.
It's happening.
Good to know. Good to know for sure. So Emily, this has been fantastic. Thank you for all of the background knowledge, the insights on this entire market, and all the details on how Linea works and your plans for going to market. Last question, and this is one we ask everyone that comes on the show, is a more general question, and it's how do you see crypto, Web3, whatever you want to call it, evolving over the next 10 years? Right, it's kind of a long timeline. Again, I just said earlier, it's very difficult to predict the growth of knowledge or this industry. But like, where do you at least hope things go? Like, how do you hope things play out? What do you hope we're thinking about in 10 years in the space? Would love your insights there as well.
Oh God, 10 years. How old will I be in 10 years? What will be the things I care about in 10 years? Yeah. Oh goodness. This is actually, I don't know if this is also a hot take. In 10 years, I would love to see, I feel scared admitting this in public, but I think again, like for true adoption, all of this like intricacy knowledge about specifics needs to just go away. Like Web3 as a term just fading back into just web, right? It just is the internet. That's what I would love to see on like the state of opinion, right? On blockchain in 10 years. I don't know if that's achievable in 10 years, to be honest. Um, but in terms of like use case and stuff like that, I'm still a big fan of just like the fluidity of financial kind of primitives, right? I think especially, I have to say, stepping into blockchain and meeting such a global community, like I have never more in my life like felt the friction of trying to like send funds internationally when paying each other meals. Like when we meet up in like random country X. So there's that piece of it that I'm really excited for, that like our, I guess, traditional banking systems will just like have that kind of built-in blockchain transfer in the background for kind of these international payment schemes. That would be the thing that I think would affect my life the most right now. That would be nice. But aside from that, again, like I said, gaming is actually what I'm really excited about. I think what I would really love to see is actually like a true interoperable game world existing. Kind of a bit of background. I play Dungeons and Dragons, so the idea of like carrying like what I really love to do with my games, like my RPG worlds or whatever, is like things from like my campaign one will carry over into campaign two. And we think about the interoperability of blockchain, right? That kind of mindset of like immersing yourself in a world and allowing you to continue play with those assets in different worlds and environments is like a very strong kind of resonating part of like my background, right? So in 10 years, I would love for that to happen too. So two things, like international, like Venmo, like splitwise thing, and then like Dungeons and Dragons on chain. That's what I want. And then no one says the word Web3 because it's just part of their life.
Yeah. No, on the Web3 fading into the background thing, you're actually even some of the most technical. I love the tech. I'm in it for the tech people that love talking about the technology. Most of the people we have on this show are like you. They're very technical, but they kind of hope for the same thing, because there is an understanding that, if I had to tell you that I was sending you a message over SMTP, if I wanted to send you an email, literally no one would use email. So um, at least we all seem to be getting it now. And those use cases that you also mentioned as well are things that I think a lot of us are excited for. So we'll definitely keep an eye out for things that deploy on Linea. We'll definitely keep an eye out for the Linea voyages. We'll put a bunch of links in the show notes about what's next for you and the team. But before we part ways today, is there anything else that you'd like to say to our listener base? Anywhere you want to point them? Any other final messages?
Yeah, I guess follow us on Twitter at LineaBuild, ILNEABUILD. Get really excited. Mainnet is coming this summer. So that's a little bit of a drop for you guys. Yeah. Thank you so much for having me, Sam.
Thank you for being here. We're very excited for this summer in that case. And yeah, thanks again.